Hello, everyone, and welcome to our Botanical Community Lecture sponsored by the Pennington Biomedical Research Center. This is our first virtual community event. We're happy that you've joined us, and we hope you and your family are well. As a quick note before we start, if you would like to ask Dr. Gurley questions, please post your questions in the chat whenever you like, during the lecture or the Q&A. We will read your questions to Dr. Gurley during the Q&A that follows his talk. Dr. Bill Gurley is Principal Scientist and Director of the Clinical Research Facility within the National Center for Natural Products Research at the University of Mississippi. Prior to joining the National Center for Natural Products Research in 2019, Dr. Gurley was Professor and Vice Chair of the Department of Pharmaceutical Sciences in the College of Pharmacy at the University of Arkansas for Medical Sciences Center. He is a member of the American Association of Pharmaceutical Scientists, the American Society of Clinical Pharmacology and Therapeutics, as well as the USP's expert panel on dietary supplements. Dr. Gurley also serves on the editorial boards of Clinical Pharmacology and Therapeutics and Phytomedicine, as well as the advisory board for the American Botanical Council. But most important to our Botanical Center, Dr. Gurley has been a member of the Pennington Biomedical and Dietary Supplement Research Center Advisory Committee since 2005. In that role, we quickly learned to value his insights and consider him to be a great friend of our center. He has authored more than 200 peer-reviewed publications, abstracts, and book chapters that cover topics ranging from pharmacokinetics to therapeutic drug monitoring, herbal dietary supplement safety, and herb-drug interactions. His research interests cover a lot of ground. They include mechanisms of herb-drug interactions, toxicity of multiple component herbal dietary supplements, the effects of phytomedicines and chemicals on drug metabolizing enzymes, botanical supplement use in special populations, and even botanical remedies that were used in the Civil War medicine. His recent publications are exploring issues surrounding the use of CBD products. The topic of his talk this evening is hemp. Does it help? Is it hype? Can it hurt? Welcome, Dr. Gurley.
So what's in a name? What's the difference between cannabis, marijuana, and hemp? Well, cannabis is the genus name of plant Cannabis sativa. And both marijuana and hemp are cannabis, but they differ in their phytochemical content. Marijuana contains significant quantities of the psychoactive drug delta-9 tetrahydrocannabinol, also known as THC, and it contains more than 0.3% by weight for the definition of marijuana. Hemp, however, refers to cannabis varieties containing less than 0.3% THC by dry weight. Now, many of you may be quite familiar with the morphology of cannabis species. For those familiar with botany, you can easily discern the two different general varieties of cannabis. You can clearly see the difference in morphology of the fiber type or industrial cannabis variety on the left, and then the drug type variety on the right. The fiber type has more exposed stalk, fewer leaves, and typically has low levels of the psychotropic drug THC. And again, THC, that's the material, the compound that gives you the euphoria, makes you high. The drug type variety, also known as marijuana, has greater leaf and flower density and produces significant levels of THC, much unlike the fiber type. Today, however, there are strains of the drug type that have low THC levels, but significant levels of CBD. And so we recall that CBD, well, you may not recall, but CBD does not have any euphoric effects. And so it does not make you high like THC does. Now, cannabis is an ancient medicinal plant. It's the only genus in the family Cannabaceae. And for a while, there was debate about different species of cannabis, but it's now believed that only one species exists, but that different varieties exist based on their phytochemical profiles. And phytochemicals are just plant-derived chemicals. And so you can have varieties of cannabis that have high THC and low CBD, or high CBD and low THC, or you can have intermediate varieties as well. Both the male and female plants exist, and it's the female plant that produces the highest quantity of these, what we call cannabinoids. Now, for those less familiar with the cannabis plant, the flowers of the female plant produce structures called trichomes. And that's the site of where the phytocannabinoids and the other chemicals in the marijuana are synthesized. And so here you can see this yellow circle, we can see a flower, or what's known as a bud, that's covered in trichomes. And then there's a closer view of the trichome at the end of that yellow arrow. And again, those are where the phytocannabinoids are manufactured by the plant. And these various phytocannabinoids and other chemicals that are unique to cannabis have various pharmacological activities. Now, there's another group called the terpenes, and the terpenes are another category of phytochemicals, but they give cannabis its unique aroma. And I'm sure that many of you are probably familiar with the unique aroma of cannabis. We'll just leave that at that. All right, so I want to give a little chronology of the history of cannabis, primarily as it's related to the United States. But cannabis has a long history of medicinal use dating back to the ancient Chinese and Sumerians. But in the United States, early settlers often grew the fiber type hemp as a cash crop, mainly as a source for rope fiber. And you can see the fibrous material associated with the stalks in the lower left-hand corner of this figure. For almost 100 years, cannabis was listed in the United States Pharmacopoeia as a medicinal plant. And it was a common ingredient in patent medicines of the late 19th century and early 20th centuries. And by 1936, most states had already enacted some types of legislation regulating marijuana simply because of its euphoric properties. Things changed, however, in 1937 with passage of the Marijuana Act. And that made it illegal to possess or sell cannabis except for medicinal uses. Now, the Marijuana Act also required physicians and pharmacists who prescribed or dispensed marijuana to register with federal authorities and pay an annual tax or license fee. Well, because of that, the prescribing fell out of fashion simply because they didn't want to have to deal with the extra hassle. Now, in the 1960s, the chemical structures of CBD and THC were identified. And then soon after, the National Institute of Drug Abuse, also known as NIDA, became the sole administrator of the federal contract to grow cannabis for research purposes. And it was the only legal source for cannabis in the United States. And it just so happened that the University of Mississippi was first contracted by NIDA and has been continuously contracted by NIDA since 1968, and where we grow several acres of cannabis depending upon the research demands of NIDA. I just want to mention quickly that the University of Mississippi is home to one of the oldest and most advanced centers for cannabis research in the world. Now, continuing with our chronology, in the 1970s, Congress placed cannabis on the list of controlled drug substances. And then not long after that, a few states began to decriminalize marijuana. And then by the 1990s, 5 states and the District of Columbia legalized the medical use of marijuana. And then in the 2000s, a second wave of decriminalization came about and more states legalized marijuana for medicinal use. Currently, there are 16 states that have legalized marijuana for its medicinal purposes. And then in 2012, Colorado and Washington actually legalized marijuana for recreational use. Now, coming up closer to the present, in December of 2018, the United States Agricultural Improvement Act, or also known as the Farm Bill, was passed. And that defined the difference between marijuana and hemp and removed hemp from the auspices of the Controlled Substances Act. The Farm Bill placed the regulations for cultivation, processing, and marketing under the purview of the United States Department of Agriculture. Now, individual states that are interested in hemp growing, they have to devise their own regulatory programs that are in line with the USDA guidelines that are laid out for hemp growing and for hemp testing. The bill also makes hemp as an eligible crop under the federal crop insurance program. It also allows for the lawful transport of hemp-derived products across state lines, provided that the hemp was lawfully produced according to USDA guidelines. And the bill, however, it really didn't define the regulatory status of hemp products. So in other words, it did not define them as foods or dietary supplements. And we'll talk about the regulatory limbo that hemp is in a little bit later in the talk. Now, based on the myriad products currently on the market containing CBD, you would think that, I mean, we are literally inundated with many types of CBD containing products. More traditional ones are the oils and the capsules and soft gel capsules and even gummies that many of you may be taking that have CBD or hemp extract. There are also some fairly exotic dosage forms out there, like hair gel that's infused with CBD, toothpicks infused with hemp, personal lubricants that may be infused with CBD, hand sanitizers with CBD, and I've even seen some bed sheets that have been infused with CBD. I'm not sure what the purpose of that is, but nevertheless, maybe it'll make you sleep better. We'll see. Of course, many people give CBD containing products to their pets, and that's a very highly popular market niche at the moment. But despite their seemingly ubiquitous distribution, the FDA does not legally recognize them in any official regulatory category at the moment. And again, we'll talk more about that later. All right, so to give you an idea of how CBD products get to market, I'll use a general process currently underway at the University of Mississippi. So on the upper left-hand corner, we start with mother plants. And these are well characterized for their genetics, their phytochemical content. And then these are planted and cultivated and harvested, and then they're processed. And then the processed material is then extracted, either with ethanol or other organic solvents or supercritical fluid carbon dioxide, in order to remove the CBD and other important phytochemicals. The extract, as you can see there in the bottom right figure, looks a lot like just dark green molasses. But then we package that and we label it, and you'll see that finished product on the far left-hand corner is actually an FDA-approved cannabis extract that's currently being used to treat drug-resistant epilepsies in children at the medical center in Jackson, Mississippi. All right, so here are a few more cannabis-derived materials that you can find at the University of Mississippi. And then all of these originate from the harvested and processed dry cannabis biomass. You can see there in a big 50-pound or a big, I forget how many gallons that is, but a barrel of the cannabis biomass. You can also maybe familiar with cannabis cigarettes, joints, or doobies, as you might want to call them. And of course, University of Mississippi makes all of these for NIDA, for their research purposes. You may not be as familiar with purified CBD. There's some purified CBD crystals in the upper middle figure. To the right of that, some purified THC oil. And then at the bottom is a cannabis extract. And so it looks more like tar than anything else, but just wanted to show you some of these sources of some of these materials that we're talking about. All right, with the large number of CBD containing products that are on the market and the creativity of a lot of the labels, things can get a bit complicated for the typical consumer. There are several subtleties when it comes to the names and labeling of oil type products that are on the market. And so the terms in red here to the left are commonly used to convey that the product likely contains CBD. And I say likely because they may not always contain CBD. Terms like those in yellow are simply too vague to know what's in them, if anything. And then hemp seed oil does not contain CBD, but rather it contains several fatty acids that are used as food components and for cosmetic purposes. So I just want to throw out some of the terminology there with regards to the various types of oils that are out there on the market and their labels. All right, so continuing on, hemp seed oil. We'll focus on hemp seed oil for just a second. It's known as a grass food additive, and GRAS in this case is an acronym for generally recognized as safe. And again, hemp seed oil does not contain any CBD or any other phytocannabinoids. Now, terms like hemp CBD oil can be a bit more vague, and it could be construed as either hemp seed oil, corn oil, or with CBD, or it could be olive oil with pure CBD dissolved in it, or it could be a wide variety of things. The same holds true for names like cannabis oil, CBD oil, full spectrum CBD oil, and such. And so when purchasing a CBD oil product, there's a few questions you should probably ask yourself. And the first one is, from what is this product prepared? Is it hemp seed? Is it hemp? Is it pure CBD? what's the phytocannabinoid content? You know, how much CBD is it supposed to have? Does it have any THC? You may or may not know that just by looking at the label. What's the vehicle? We're finding out with some of our research that the vehicle can have a significant impact on the efficacy. So whether it's hemp seed oil, sesame oil, or olive oil. And then what's the intended use? You know, why do you want to use this particular product? And is there evidence out there to suggest that it might be helpful? All right, so continuing on with some more terminology, I just want to define some of these because we're going to be using them throughout the talk. So a cannabinoid is a molecule that activates a unique set of receptors within the human body that regulate various physiological processes. Collectively, cannabinoids and their receptors, and then the enzymes that either synthesize or degrade them all constitute what's called the endocannabinoid system. Now, endo is a prefix for the word endogenous, and that just simply means produced within the body. So there are two principal endocannabinoids, primarily known as anandamide and then 2-AG. 2-AG is just a shorter version of the compound 2-arachidonyl-glycerol, so it's a wonder why you call it 2-AG. And these, both of these compounds can be formed in just about any cell types. They act upon the variety of cannabinoid receptors. Now, in contrast to endocannabinoids are phytocannabinoids, and the prefix phyto just refers to the word plant. And so these are cannabinoids that come from the cannabis plant. And that includes both THC and CBD, as well as more than 100 other different phytocannabinoids. And these can also activate various receptors and modulate various cannabinoid degrading enzymes. Now, it was during the search for THC's mechanism of action, and then back in the 1980s, that led to the discovery of the cannabinoid receptor, and then eventually the endocannabinoids, and ultimately this whole endocannabinoid system. So, as I mentioned, cannabis is one of the most studied plants in medical sciences. There's well over 10,000 papers published today. More than 500 phytoconstituents have been identified in cannabis, including more than 110 phytocannabinoids. Now, the chemical structures shown here to the left illustrate some of the more subtle differences between a few of the more recognized phytocannabinoids like CBD and THC, and then CBN, TCHV, and CBG and CBC. All these are just acronyms for much longer chemical names, but nevertheless, these are some more common phytocannabinoids that can be found in hemp. Now, we'll find out that some of these small structural differences can give rise to significant pharmacological differences. Now, an important step in the generation of CBD or THC is that the plant material must be heated to convert what's called a precursor carboxylic acid to the decarboxylated compounds like THC and CBD. So you'll notice that there's these carboxylic acid moieties, they have to be removed, and that's removed by heating, and that turns it into these decarboxylated compounds, primarily THC and CBD. And these carboxylic acid precursors are not nearly as active as their decarboxylated products. In order to decarboxylate hemp, you have to heat it up to at least 230 degrees Fahrenheit, and that can preferably at least for 60 minutes or longer. Of course, if you're smoking or if you're vaping hemp or marijuana, then these carboxylic acid precursors are quickly decarboxylated. But if the dried plant material is not sufficiently heated, you'll get very little THC or very little CBD generated. Now, just kind of continuing on with this theme, we can see here, this is some pie charts of some different materials: raw hemp oil, decarboxylated, and distilled hemp oil. And we can see that decarboxylation, then followed by distillation, can increase the CBD content. And so the raw hemp oil may start out with about 4% CBD, and then once it's decarboxylated, going to the right, it can up it up to about 10% CBD. And then if it's distilled, what happens during the distillation process is you remove a lot of these terpenes and because they're fairly volatile compounds, and then you can concentrate the CBD. And so you may go from as little as 4% CBD to the final distilled product, which has about 25% CBD. So now, not all hemp extracts are distilled, so the content of CBD in the various products will vary depending upon the type and the extent of the processing. All right, so with regard to cannabinoid chemistry, notice that there are significant structural differences between the phytocannabinoids on the left, the endocannabinoids in the center, and the synthetic cannabinoids on the right. Now, one physical chemical similarity common to all of these compounds is that they're very lipophilic, which means that they're highly fat soluble, or they have very poor water solubility. Now, the synthetic cannabinoids on the right are much more toxic than their natural counterparts, and they've been linked to a wide variety of serious adverse events. Also, the synthetic cannabinoids are often found as adulterants in many CBD oil vaping products. And we'll talk about that a little bit later. Now, this endocannabinoid system that we've alluded to is considered a key participant among all the other recognized organ systems within the human body. And the endocannabinoid system influences every organ system within the body, and it has some regulatory capacity. The endocannabinoid system, as I mentioned earlier, encompasses the endocannabinoids, their receptors, and their synthesizing and degradation enzymes. It's now recognized that the endocannabinoid system communicates with every other organ system and plays a key role in maintaining what we call homeostasis. Now, this is just kind of a summary of the basic components of the endocannabinoid system. We'll see that apart from, again, all this kind of came to fruition during a search for THC structure and its mechanism of action back in the 60s and then early into the 80s. There are several receptors that can participate in the endocannabinoid system. The two most studied are the cannabinoid 1 receptor called CB1 and cannabinoid 2 receptor, or CB2. And both of these are for the pharmacologists in the audience tonight. These are G protein coupled receptors. Then other G protein coupled receptors that are important in the endocannabinoid system are one called GPR55, and there's another one called GPR18 and GPR19, and there's a few others. But there are also ion channels that can also be receptors. These are ligand-gated ion channels for phytocannabinoids, and one in particular is called TRPV1. Now, looking at the endogenous ligands, or the endocannabinoids, the two most common, or two most well recognized, are anandamide and 2-AG, and they're both ligands for the receptors, but they're also substrates for these degradative enzymes. And so the production and then the elimination of endocannabinoids are controlled by these various enzymes. And there's also certain transporters that facilitate the endocannabinoid movement within and between cells. So it's a fairly complex system involving receptors as well as enzymes and transporters. All right, so let's talk a little bit about some of the endocannabinoids in more detail. As I mentioned, anandamide or 2-AG are the two principal endocannabinoids. They can both activate CB1 and CB2 receptors, as well as a few others. They're synthesized from what we call phospholipids. These are fatty molecules that were in all of our cell membranes. And they happen to be derivatives of a compound called arachidonic acid. And that molecule serves as a backbone for a wide number of lipid mediators in the body. You may have heard of things like prostaglandins and leukotrienes, and all of these have their origins in arachidonic acid to some extent. Now, anandamide and 2-AG are primarily degraded by these enzymes. One is called hydrolase or a lipase. And so for anandamide, the principal degrading enzyme is called fatty acid amide hydrolase. And for 2-AG, the principal degrading enzyme is called monoacyl glycerol lipase, or MAGL. Just leave it at that. And then both of these endocannabinoids are transported by fatty acid binding proteins. right? And depending upon their synthesis and their degradation, the residence time for these endocannabinoids within the cell can be very, very short. All right, so I just want to give you an idea of what some of these things look like and how they are synthesized and transported. All right, so let's talk about some of the receptors. So the cannabinoid receptors are found in almost every tissue throughout the body. The CB1 receptors are primarily concentrated in the central nervous system. And it just so happens that CB1 is the most abundant G protein coupled receptor in the brain. So I'll just do that out there for the pharmacologist. I think that's quite interesting. The CB2 receptors are found in various immune cells, but they can also be found in other tissues throughout the body as well. And together, CB1 and CB2 help maintain homeostasis. And that just simply means the process of maintaining optimal conditions for normal bodily functions. And so this cartoon, you can see the wide distribution of CB1 and CB2 receptors throughout various organs and tissues in the body. You can understand why there's so many, by looking at this, you can understand why there's so many potential uses for CBD. Now, this is primarily for the pharmacologist and healthcare professionals in the audience. I don't want to get too deep in the weeds, but this is a cartoon of two separate nerve synapses. And so quickly, the endocannabinoids are synthesized by membranes in what we call this postsynaptic membrane. And then they go to the surface of the neuron cell, and they're actually transported what we call in a retrograde fashion to the CB1 receptor in what's called the presynapse. And so once the CB1 receptors and these presynaptic CB1 receptors are activated, they can basically stop the release of various neurotransmitters. And they do that by inhibiting certain calcium transporters. Again, I don't want to get into too much the molecular pharmacology of it, but they can affect both excitatory and inhibitory neurons, and they can affect both excitatory and inhibitory neurotransmitter release. And again, without going into a lot of the gory details, the molecular aspects of this, just consider the endocannabinoids acting kind of like a governor on an engine, or the shut-off valve on a gas pump to keep your gas tank from overflowing. That basically keeps things from getting out of control. And so, as I mentioned, they can control both excitatory and inhibitory neurons in the central and peripheral nervous systems, as well as other organs, systems, and even the immune cells. And again, they do this. By doing this, they act as principal regulators of homeostasis in the body. Now, focusing on the right side of this slide, you'll see depictions of two other cell types that are in the brain, primarily astrocytes and microglia, and they also have receptors for the endocannabinoids. And the astrocytes, they have numerous functions within the brain. They help maintain normal brain function and basically keep the neurons working properly. And the roles the endocannabinoids play in astrocytes is just a little more unclear than it is in the other cell type known as microglia. And the microglia, they're basically the immune cells of the central nervous system. And they're involved in modulating inflammatory responses in the brain. And so when these endocannabinoids like 2-AG or anandamide act on these receptors in the microglia, they can block the release of what's called inflammatory cytokines. And so these microglia or many other immune cells, one of the ways that they exacerbate an immune response or an inflammatory response is by releasing these proteins called cytokines. And so the endocannabinoids can inhibit the release of those. And so this inflammation is a hallmark of many neurological ailments. And by blocking the release of these cytokines, they can hopefully ameliorate some of the symptoms of diseases like multiple sclerosis or Alzheimer's or Parkinson's and the like. Okay. Now, really don't get freaked out over this one, because this is for the biochemists that are in the audience. And all this does is just depicts the various cellular lipids that are involved either directly or indirectly in the endocannabinoid system. So you notice there's a kind of a light brown area at the top and bottom of the slide, and that represents the cell membrane, and that white area in the middle is the interior of it all. So there's a lot of stuff going on there. These are primarily lipids. And so all the colored boxes and arrows indicate molecules and pathways that are relevant to the endocannabinoid system within the cell. And so you'll notice that you may have some arrows, and those are basically indicate activation. And you'll notice there's some other lines that look like elongated T's, or they have a horizontal bar at the end, and those are situations where that particular lipid may inhibit that particular receptor. So you notice that there are certain types of receptors on the membranes, and then there's various mediators can activate or inhibit these particular lipids, on these particular receptors. So what I want to do is just focus on the endocannabinoids that are in the red box here. And notice that below that, they can activate CB1, CB2, as well as another one called TRPV1. And they can inhibit other ion channels, like in this case, a calcium channel. But notice that THC and CBD also activate these cannabinoid receptors. And they're located just throughout the cell membrane and throughout various types of cells. We've even got some that are a little bit less conventional. All right, so what I want to do now is let's consider how all these receptors contribute to the pharmacology of CBD. All right, so let's talk about CB1 first. It was the first endocannabinoid receptor identified and characterized. It's, as I mentioned, it's widely expressed in the central nervous system, among other tissues. And both anandamide and 2-AG are ligands for CB1. And CB1 plays a role in memory, in appetite, stress, gastrointestinal motility, blood pressure, sleep, pain, emesis, a wide variety of things. And so by bonding to CB1 in the brain, THC promotes a sense of euphoria. All right, so that's what gives you the high, because THC acting on CB1 in the brain. It's also responsible for THC causing the munchies. And for those of you that are partaking of the herb, you certainly understand what that means. And it's also why THC is an excellent antiemetic. In fact, there are actually drug-approved compounds that are purified THC that are administered to prevent nausea and vomiting in cancer therapy. So it's an excellent antiemetic. All right, and all those are mediated by CB1. Now, CBD, unlike THC, does not activate CB1. Now, technically, again, this is for the pharmacologists in the audience. It acts as what we call a negative allosteric modulator. Well, what the heck does that mean? Well, basically, it just means that in the presence of CBD, the effect of the endocannabinoids at CB1 is dramatically diminished. They're not negated, but they're diminished. So in short, CBD's influence on CB1 is not as great as it may be at other receptors. And so the bottom line is that that's why CBD doesn't make you high. Now, with regards to the second endocannabinoid receptor, CB2, it's widely expressed in the immune system, as well as the brain and the gut and the peripheral nervous system. And its principal ligand is 2-AG. And then when it's activated, CB2 modulates various aspects of the immune response. It can certainly reduce inflammation, relieve pain, and even inhibit gut motility. It acts as what we call an inverse agonist at the CB2 receptor. CBD acts as an inverse agonist at CB2. And what does that mean? Again, another pharmacology term. Basically, it means that when CBD binds to CB2, it renders the receptor incapable of responding. Right? And CBD's major effect on CB2 is to reduce the inflammatory response by preventing the migration of immune cells, principally leukocytes, to affected areas. So remember, we talked about those immune cells that secrete those cytokines. Well, those immune cells have to move to a site of injury to exacerbate an inflammatory response, and CBD stops that migration, that what we call chemotaxis. Anyway, all right, a third receptor called GPR55. It's also considered to be, some people refer to it as CB3, but nevertheless, it's widely expressed in the brain and the intestine in certain cancers. Its physiological role is a bit unclear, but it appears to have a role in pain, inflammation, epilepsy, and even cancer metastasis. Now, CBD inhibits the activity of GPR55, and that may explain CBD's effectiveness in relieving pain and certain epileptic seizures. The last receptor we'll talk about is called TRPV1. You may also hear it referred to as the vanilloid receptor or the capsaicin receptor. And it's actually, unlike the other receptors, it's an ion channel, and it's found throughout the peripheral nervous system. And then when activated, this particular ion channel helps transmit pain signals, typically pain evoked by heat and chemical irritants like capsaicin. And for those of you that may not be familiar, capsaicin is the chemical compound in hot peppers that makes your mouth burn. And so, although CBD activates this ion channel, it quickly desensitizes it, which makes it less capable of transmitting a pain response. So the longer CBD is in contact with this receptor, it starts to desensitize it and make it less active. Now, apart from these receptors we've talked about, there are a whole host of other receptors that CBD acts upon, and I've listed a few here: serotonin receptors, adenosine, opioid receptors, and a few others. And so when you have an understanding of the wide variety of receptors that CBD can act upon, you can kind of understand why it's promoted for so many different indications. What this means is that CBD is a very non-selective phytocannabinoid, which means that it acts upon a wide variety of receptors, not just a select few. In other words, this non-selectivity accounts for the many health claims often attributed to CBD and to hemp. All right, so this slide just summarizes the wide variety of cannabinoid and non-cannabinoid receptors affected by CBD. And so having the capability to act upon so many receptor types, it's easy to understand why CBD appears to be this so-called proverbial panacea. Now, the question now is, does this capability and all of its pharmacological promise, does that translate to the real world conditions? And that's what we're going to look into next. Okay. Well, I'll take that back. A couple of other things I want to mention before we move into the clinical trial assessments. And that is that CBD doesn't just act on receptors. Apart from its activation of the receptors, it also modulates some of these degradation enzymes. And for example, CBD inhibits fatty acid amide hydrolase. And again, this is the enzyme that breaks down anandamide. And so by inhibiting this, the activity of this of FAAH, CBD indirectly increases anandamide levels in the synapse to act on CB1. And so, again, it doesn't inhibit the degradation enzyme for 2-AG, but it primarily inhibits FAAH. And so, again, by doing so, it can dramatically, but it can certainly increase the levels of of endogenous anandamide in the synapse to act on those presynaptic CB1 receptors to control a neurotransmitter release. All right, this is the last crazy diagram, and then it won't be not too much after that. Again, this is for the biochemists that are maybe in the audience. We're primarily looking here at various enzymes that are either involved in the synthesis or in the degradation of various lipid mediators. And what I want to focus on here are the ones here in red. And we can see that's fatty acid amide hydrolase, and that's the enzyme responsible for the breakdown of anandamide and to some extent 2-AG. But as I mentioned, CBD inhibits the activity of that enzyme. And so by doing so, it can indirectly increase endogenous levels of anandamide. We also mentioned that CBD inhibits fatty acid binding proteins. And it's these fatty acid binding proteins that carry anandamide and 2-AG to the hydrolase enzyme. And so if you inhibit both its transport to and its degradation, you can certainly understand why CBD can increase these endogenous levels of these endocannabinoids. And so it's kind of a double-edged sword with regards to those enzymes. All right. In fact, we just recently published a study showing the fact that CBD dramatically reduces the expression of these fatty acid binding proteins. So again, they just kind of helps you understand the various mechanisms involved with CBD within the body. All right, so now we've been kind of focusing on phytocannabinoids, but the phytocannabinoids aren't the only phytochemicals in hemp. There are things called non-cannabinoids, things like various terpenes, particularly the terpenoid called beta-caryophyllene, as we show the structure here at the lower left-hand corner. And then there's another terpene called limonene. And so these compounds are primarily act as antioxidants. And these, what does that mean? Well, an antioxidant serves to neutralize a group of reactive compounds in cells called free radicals. And these free radicals oftentimes initiate and propagate inflammatory responses. And so as a result, antioxidants can mitigate inflammatory responses that are the hallmarks of many diseases. Now, that's all well and good. The question is how much of these terpenes and terpenoids can actually get to the site where this inflammatory response may be mediated. So we'll talk about why that may be a problem a little bit later. All right. Now, hopefully you have a feel for the various types of phytochemicals that are found in hemp and maybe at least a cursory understanding of their pharmacology. So now I want to talk about a few more terms, one called full spectrum hemp as well as broad spectrum hemp. And so what do those terms actually mean? Well, full spectrum hemp is a hemp product that contains phytocannabinoids, including less than 0.3% THC, as well as a wide variety of terpenes, terpenoids, flavonoids, and other phytochemicals present in hemp. In other words, the product has the full spectrum of cannabis phytochemicals present. Now, broad spectrum hemp is simply full spectrum hemp without any THC. And of course, there are other products that may contain only purified CBD or purified versions of other phytocannabinoids like CBG and CBN. And so the purpose of using a full or broad spectrum product is that the complex mixture of phytochemicals, coupled with their varied pharmacological properties, can provide a benefit that we call the entourage effect. In other words, these complex phytochemical mixtures give you more pharmacological bang for your buck. Now, given the wide variety of receptors that CBD appears to be able to modulate, it's no wonder that a wide variety of diseases and maladies may benefit from CBD. And this is just a list of some of the promising areas of CBD therapy. You know, it can help with anxiety, inflammatory conditions, pain, perhaps in diabetes with regards to glucose tolerance and insulin sensitivity, may have some anti-cancer effects. Appears to have some antioxidant effects, can modulate the immune system, may help you breathe better with regards to its effects on the lungs. But you know, there are some researchers that suspect that there's a thing called an endocannabinoid deficiency syndrome, and that might underlie many diseases, as the basal levels of many endocannabinoids are oftentimes disrupted in a wide variety of diseases like post-traumatic stress disorder or migraine or fibromyalgia and such. Of course, that's not the only factor involved in disease etiology, and just because your endocannabinoids are disrupted doesn't mean that's causing the disease, but nevertheless, this endocannabinoid deficiency syndrome is an interesting hypothesis that certainly merits further investigation. Now, from all the available research, it certainly would appear that CBD is the proverbial panacea. However, there are a host of issues that can affect whether the bench research in CBD's mechanisms of action translates into efficacy when these things are ingested as commercially available products. Now, based on what we know about CBD and hemp pharmacology, it's no wonder that these products claim to be functioning as anticonvulsants, neuroprotectants, analgesics, anti-cancer agents, anti-anxiety agents, antipsychotics, antidiabetic agents, and so on and so forth. The big question is, how effective is hemp and CBD? What clinical evidence is out there that can back up these various claims? So what I want to do next is kind of go through some of the clinical trial results that have looked at CBD and hemp in various disease states. All right, so To date, there are more than 600 clinical trials that have been registered with the federal government investigating the effectiveness of phytocannabinoids. Most of these involve either THC or THC and CBD combinations. However, there are a large number of clinical trials that involve just CBD or hemp. And these are just some of the conditions that are currently under investigation for the utility of hemp and CBD. And so what I want to do next is just review the results of several of these clinical trials that are aimed at assessing the efficacy of hemp and CBD in these particular disease states. Now, it's well established that CBD is effective in treating certain drug-resistant epilepsies, particularly a group of epilepsies known as Dravet syndrome or Dravet syndrome and Lennox-Gastaut syndrome. And actually, there's a purified CBD product called Epidiolex that was approved by the FDA in 2018, and it's been approved to treat Dravet syndrome and Lennox-Gastaut. Now, to date, there have been more than 25 randomized controlled clinical trials that have demonstrated the efficacy of Epidiolex in reducing the frequency and the severity of seizures in this particular patient population. Now, the doses required to do this are oftentimes quite large and are usually much greater than might be attainable from commercially available non-drug products that contain CBD. Now, there was a small clinical trial investigating the efficacy of CBD in treating Parkinson's disease, and they used both a low and high dose of CBD for 6 weeks. But CBD was no different than placebo in affecting the Unified Parkinson's Disease Rating Scale. So unlike epilepsy, at least in this small trial, it didn't appear to be efficacious in Parkinson's. Now, another neurodegenerative disease, multiple sclerosis. There is an approved drug combination that has 50% THC and 50% CBD called Bixamols. The trade name is Sativex. And Sativex has been approved in the United Kingdom, and it's used actually in the United Kingdom to treat spasticity in multiple sclerosis. And spasticity is just simply an inability to move your muscles in a voluntary fashion. Many of these randomized controlled clinical trials with Sativex have been shown to improve spasticity, as well as neuropathic pain in multiple sclerosis patients. And clearly the efficacy is likely due to both THC and CBD. Now, as I mentioned, Sativex has been approved as a drug in the UK, but it has yet to be approved here in the United States. I know it's currently undergoing the approval process, but it hasn't been approved as of yet. All right, we're kind of looking at some psychiatric diseases indications. There was a published trial of CBD effectiveness in 36 patients with schizophrenia using 600 milligrams for 6 weeks. And it too showed no improvement in clinical endpoints compared to placebo. So once again, a negative outcome. With anxiety, there was a small study of 12 subjects that had generalized anxiety disorder, and they were administered 600 milligrams of CBD prior to preparing for a videotaped public speaking event. And no, I didn't take any CBD before my talk this evening, but probably should have. Nevertheless, there were several psychological and physiological endpoints that were evaluated in the study, and it was shown that CBD significantly reduced several measures of anxiety, as well as cognitive impairment and measures for discomfort in speech performance. And so, so that was a positive outcome for CBD in this small study looking at its effects on anxiety. Autism spectrum disorder, there was one small study. They really didn't look at efficacy here. This was primarily more of a proof of concept. So they administered Epidiolex to 17 patients with autism spectrum disorder, and they looked at neurotransmitter balances. And so they looked primarily at glutamate and another neurotransmitter called GABA. And they found that CBD significantly decreased GABA levels in those with autism spectrum disorder, but they didn't look at the effects of multiple doses or whether or not it actually had any efficacy after multiple doses in autism. But nevertheless, it was an interesting proof of principle study to show that CBD does appear to modulate these particular neurotransmitters. And so that's in line with its pharmacology. With regards to fibromyalgia, which is probably a lot of people are taking CBD for fibromyalgia, there was one small trial in 20 patients that had fibromyalgia, but they found no improvement in clinical pain endpoints compared to placebo when CBD was administered via inhalation. So they vaporized it and then inhaled the CBD, but there was no improvement in the clinical endpoints with regards to fibromyalgia. Another study involved with pain. There are 94 patients taking opioids for chronic pain were administered a CBD-rich hemp extract for 8 weeks. And at the end of 8 weeks, CBD demonstrated no significant effect on any of the pain indices. However, 50% of the subjects did reduce their opioid use by studies in. So that may be certainly can be construed as a positive outcome. With regards to cancer pain, there have been 3 randomized trials, clinical trials evaluating the effect of various doses of nabiximols, or this is Sativex, on the cancer-associated pain in more than 400 subjects. And again, they found no significant improvement in any of the pain scores when compared to placebo. Moving to some GI disorders, a study with 29 patients with ulcerative colitis received 250 milligrams of a CBD-rich hemp extract twice daily for 8 weeks. And again, the extract was no better than placebo on the percentage of patients who went into remission at the study's end. So again, another negative finding with regards to GI issues. Another GI study looking at Crohn's disease. 19 patients were self-administered 5 milligrams of CBD under the tongue twice daily for 8 weeks. And again, much like the ulcerative colitis study, there was no difference between CBD and placebo on the Crohn's disease activity index. Okay, so another negative finding. This is an interesting study I wanted to include. And it examines what's called inflammation-induced gut hyperpermeability. What does that mean? Basically, it referred to it as a leaky gut. So the study was to see whether or not CBD could minimize the aspirin's ability to promote gut leakiness. And so aspirin is well known to cause localized gastrointestinal irritation, and they can certainly increase the permeability in the gut. And so a leaky gut is common to several gastrointestinal diseases, and that can also have some untoward systemic effects. And so what they did is they evaluated the appearance of 2 large, and I say large meaning large molecular weight sugars that are usually poorly absorbed when you take them orally. But if they appear in the urine, then it means they're getting across the gut mucosa. And so the more of these 2 sugars that appear in the urine, the more leaky the gut is. And so that's a way to assess the permeability of the gut wall. And they found that over 6 hours, CBD significantly reduced this inflammation-induced gut permeability. So it may be a way to influence this leaky gut syndrome. With regard to diabetes, probably one of the more important disease states that we're concerned with. Again, one small study of 13 subjects that had type 2 diabetes were given 100 milligrams of Epidiolex twice daily for 13 weeks. 35 primary and secondary endpoints were evaluated, and after the 13-week period, CBD had no effect on any of the endpoints at that time. So again, another negative finding. With regards to intraocular pressure, this was a study looking at, so again, a small study, assessing the sublingual phytocannabinoid administration on ocular hypertension in 6 patients with early open angle glaucoma. And they found that 5 milligrams of THC reduced intraocular pressure after 2 hours, whereas 20 milligrams of CBD had no effect, but 40 milligrams of CBD actually increased intraocular pressure. So that would not be a good finding if you're having glaucoma. So that may be an indicator not to utilize CBD for individuals that have glaucoma. THC, on the other hand, may have some benefit. This is the most recent study that was published actually this week. And it's a study of a commercially available hemp extract formulation, and they looked at 39 different measures of either body composition, blood chemistries, or psychometric measurements. But in all of those various indices that they evaluated, only high-density lipoprotein cholesterol was significantly improved after 6 weeks. Now, there were some psychometric indices like perceived sleep and perceived stress relief and perceived life pleasure that were positively impacted, but the only one that was statistically significant was a slight increase in HDL cholesterol, which is not a bad thing, but a wide variety of other things were not affected by that particular small dose of CBD. All right, to kind of summarize, when we look at all these published randomized controlled clinical trials together, it's clear that the drugs Epidiolex or Sativex do have efficacy in treating drug-resistant epilepsy as well as multiple sclerosis. Now, a small number of clinical trials did show efficacy for hemp or CBD in either anxiety, gut inflammation, or the reduction of opioid use, but the vast majority of the studies found CBD to be no better than placebo. So why is there such disparity in the clinical trial findings? And do other factors influence the clinical trial results? Well, the short answer to that second question is a resounding yes. Now, one of the most important factors that can influence the effectiveness of CBD is the fact that only about 6% of a CBD oral dose is actually absorbed. And so again, this is because CBD has very poor water solubility. So the best way to improve CBD absorption is to take it with meals, especially meals that have a high fat content. And so the diagram to the right looks at the effects of either food or taking CBD in either a fasted state or in a fed state. And the fed state has a fairly high fat content in the meal. And so the blue squares in line is basically an assessment of CBD levels in the blood over a 72-hour period after they took a 1,500 milligram dose of CBD in the fasted state. And then the green circles in line represents the concentrations of CBD in the blood after they took it with a meal that had a high fat content. Now, if you look at the two areas under each of those curves, that may not look like they're all that different. But what you have to realize is that the y-axis of that graph is a logarithmic scale. So they're actually quite different. There's a huge difference in the areas under those curves. And so the fatty meal increased the absorption, or what we call the bioavailability of CBD, by about a factor of 5. Now, also notice looking at these curves, the peak concentrations occur around 4 to 5 hours. So that's about how long it takes for CBD to be absorbed in many instances. And it stays around for a long time. It has what we call a fairly long half-life, which means you don't have to administer it as often. But when you do administer it fairly frequently, the drug or the CBD accumulates in the body quite readily. Now, the bottom line is not only do meals affect the absorption, but also the dosage form can also affect the absorption. And so certain dosage forms are better than others. And so some of these soft gel capsules are certainly much better than dosage forms like gummies. And just to kind of illustrate this a little further, knowing that CBD has a relatively poor oral bioavailability, many manufacturers are starting to formulate CBD in what we call novel drug delivery systems. And so this slide here just shows the blood concentration time profiles for CBD in a conventional dosage form, which is in the red triangles. But a novel dosage form that utilizes what we call liposomal technology, you can see in the blue circles there, dramatically improves the amount of CBD that's absorbed. So you may start to see some of these new dosage forms or new dosage formulations on the market that are designed to improve the oral absorption of CBD. There's not a lot of those on the market yet, but I'm sure at some point they'll be probably the norm as opposed to the exception. All right, now another problem that plagues many commercially available CBD products is just poor product quality. For your conventional medications that you get at the pharmacy that are regulated by the FDA, those product labels must accurately reflect the content of the active ingredients within the container. Now, for dietary supplements, especially botanical dietary supplements, it's not uncommon for a product's content to differ quite markedly from the label claim. And this also holds true for CBD. And so what is often claimed on the label of many CBD products does not accurately reflect the actual content. In short, not all CBD-containing products are created equally. Moreover, adulteration with THC or synthetic cannabinoids is not uncommon. Now, so we at the University of Mississippi, we recently evaluated 25 various CBD-containing products purchased from various retailers across the state. And many of the product labels either had no claim whatsoever, or they had or claimed to have quite a bit of CBD. So it was a wide spectrum. And so what we did is we took these products and had them analyzed for CBD and THC content, as well as the presence of various synthetic cannabinoids. So what I want to do next is just kind of share you the results of that particular study. All right, now, data from the first 13 products are represented in this table. And the second column is the product label claim for CBD. The third column is the quantity of CBD detected within the product. Column 4 is the percent label claim. Column 5 indicates those products whose THC content exceeded 0.3%. And then the last column indicates products that contain synthetic cannabinoids. Now, in most instances, product label claims misrepresented the actual CBD content within the product. So percent label claims range from indeterminate values, in other words, there's no CBD label claim, to products that contain very little CBD, to others that far exceeded the label claim. Now, in 3 instances, the THC content exceeded 0.3%, with one product containing almost 50% THC. So if you had purchased that one, you probably were quite satisfied with the results of that particular product. An even more disconcerting finding was the fact that one product was adulterated with a synthetic cannabinoid. The second table depicts the results of the next 12 products. And then once again, percent label claims range from indeterminate values to values that were either far below label claim or in one particular case, exactly matched the label claim. But then there were also instances where little to no CBD was detected, as you see there by the yellow circles. And then there were 3 products that were adulterated with synthetic cannabinoids, and all 3 of these products were vaping oils. And we know there's been some serious issues with vaping in terms of causing a lot of lung injury, and that may be attributable to some extent to these adulterants like the synthetic cannabinoids. All right, so to kind of summarize, we found that this small sampling of CBD products acquired from retailers across the state of Mississippi demonstrated marked variability in actual content versus their product label claim. Several products had no CBD, while others contained significantly more than the label claim. One contained mostly THC, while a few others exceeded the 0.3% limit on THC. Several vaping products contained no CBD whatsoever, but were actually adulterated with synthetic cannabinoids. So clearly, many of these CBD products have little or no relation to any potential benefits of CBD itself, because if there's no CBD, it can't have any benefit. And they actually pose a range of risks to consumers, from outright fraud to overt health dangers. And so we're not alone. There have been several other studies looking at the quality of CBD products, and they found similar studies with similar results to what we found, a lot of product label claim discrepancies. All right, so now let's shift to safety. So is CBD and hemp safe? Well, here are just some of the commonly reported side effects of phytocannabinoids. And those that are highlighted in red, the psychotropic effects, they're primarily attributable to THC. So hopefully there's not a lot of THC in your CBD or hemp products. But nevertheless, CBD is not psychoactive, so you shouldn't expect that. But some of the other side effects include drowsiness, fatigue, nausea, muscle weakness. And, you know, they're not too problematic. And the reason that they occur is because CBD acts on so many receptors in so many different organ systems. Now, the most common side effects reported in the clinical trials were, fairly innocuous for the most part. But the last list, the elevated liver enzymes, they were primarily associated with high doses of that purified drug called Epidiolex. And so doses much higher than that those are doses that are much higher than would probably be achieved if you were taking a commercially available CBD product. But, again, most of the other common side effects are fairly innocuous. Now, apart from those innocuous side effects, there have been some serious effects that have been observed in a few other studies. Fatty liver and reproductive toxicity may manifest themselves with chronic CBD exposure. And for the guys out there, it's not uncommon for CBD to lower your testosterone levels. CBD can inhibit and maybe even induce the activity of several important drug metabolizing enzymes. And so if taken with conventional medications, CBD may render some drugs more toxic because it inhibits their metabolism, but it may render other drugs less effective because it induces their metabolism. And that's a whole area that our group is looking into right now, is potential herb-drug interaction or potential hemp-drug interactions that may be clinically relevant. But again, that's an area of study that's still in its infancy. Now, whether long-term exposure to low doses of CBD produces any of these untoward side effects still remains to be determined. But again, plaguing many dietary supplements as well as CBD products is their adulteration with either prescription medications, excessive THC content, or synthetic cannabinoids, either of which can have significant health or legal repercussions. Because if you take a CBD product that has a significant amount of THC in it, you will fail your urine drug screen. All right, now I want to shift gears a little bit and point out a few issues regarding CBD product labels. So I've entitled the next few slides Caveat Emptor, which is Latin for let the buyer beware. And so consumers can easily be fooled by CBD product labels, as we've typically seen with our analysis study we just talked about. And so this particular product says CBD clinic, and you might think that it contains CBD, but you would be mistaken, because the product does not contain CBD, but rather it contains menthol and camphor. So you can certainly feel the effects of menthol and camphor, but you might assume that there's CBD in the product, but it only comes from the CBD clinic. This particular CBD containing cream makes a drug claim for pain relief. So you can see boldly on the face there is pain relief cream, but it also says has long-lasting pain relief. Well, the FDA does not like these drug claims on things like dietary supplements or CBD. And so those types of products are typically, these companies will receive a nasty letter from the FDA, and then if they don't respond, then the FDA will take these products off the market. And that has been done in many instances. This particular product here is, I'm sorry, let me back up here. This particular product is a legitimate product. It contains virgin hemp seed oil, but you have to remember that hemp seed oil does not contain CBD, so don't be expecting you to have any effects from CBD from hemp seed oil. So I just wanted to throw that out there. A lot of people get confused by that. Now, this particular product here is not making any drug claims on its label. However, it does claim that the product is a dietary supplement. And CBD has not yet been deemed a dietary supplement by the FDA. And for those of you in the audience that may not know the exact definition of a dietary supplement, it's basically a product other than tobacco that's added to the total diet that contains at least one of the following. It can be a vitamin, a mineral, an herb, a botanical, an amino acid, a metabolite, an extract, or any combination of those. So it's a very broad and encompassing definition. In the term extract there, you might think, well, hey, hemp extract falls under that, but technically it doesn't, and we'll talk about that a little bit later. Also notice in their lower right-hand corner that the label displays a good manufacturing practices seal, and oftentimes that conveys that the product is of good quality, but not always. It depends upon what organization is actually sponsoring the seal. So despite being sold on shelves and online, CBD dietary supplements and foods containing CBD are still not legal according to the FDA. The FDA's primary reasoning for why CBD can't be a legal dietary supplement ingredient is that before CBD was ever sold as a dietary supplement, it was first publicly researched as an investigational new drug. And that new drug is Epidiolex. And that was, that's basically sold by GW Pharmaceuticals from the UK. But it's also here in the United States. Now, this means that under the Federal Food, Drug, and Cosmetic Acts, they have a thing called the IND exclusion clause. And that clause renders CBD ineligible to meet the definition of a dietary supplement. Now, when we're talking about foods, foods cannot be adulterated with prescription drugs. And so if the FDA views CBD as a drug, then you can't add it to foods legally because the FDA would consider that an adulterated product. Now, the 2020 spending bill that President Trump signed this past December requires that the FDA update Congress on its progress in developing a policy for the enforcement of discretion regarding CBD. And the FDA's policy has been submitted to the Office of Management and Budget, but that's about all we know at this time. We don't know any details about the policy. At least I'm not aware of any details. So in short, the regulatory status of CBD is still in limbo. And so will it become a dietary supplement, or will it be assigned a unique category on its own? We'll just have to stay tuned to find out. So hopefully we'll have some idea as to what its regulatory status will be by the end of the year. All right, so to conclude, what's the final verdict on hemp? Does it help? Perhaps, if the right product, the right dose, and the right conditions are met. Is it hype? Well, it certainly can be, unless quality products are utilized. And even then, the proper dose remains to be determined for most indications. Can it hurt? Well, this too appears to be product specific and dependent upon the dose, the duration of usage, and the concomitant use with other medications. So with that, I will conclude. Hopefully I haven't gone too far over the my allotted time, and I'll be happy to answer any questions you might have.
Thank you, Bill. We have quite a few questions, actually. So let's see. Do you want to turn on your video, Bill?
Yeah, I'll do that.
Great. So I'll start with one here. The question is, with so much variation in the actual content of CBD in retail products, what practical advice can you provide to avoid buying adulterated CBD products? That's
an excellent question. I get that a lot. So my first response to this is never buy your CBD products from your local gas station, all right? You're setting yourself up for disappointment when you do that. But I will say this, I will share something as another slide I want to put in. I get this quite a bit, and it's not an easy task to find out which products may have what's actually in the product, what's actually claimed on the label. And so there is a nice website to go to. I use it quite a bit, not only for CBD, but also for a wide variety of dietary supplements, and that's consumerlab.com. And what consumerlab.com does is that they evaluate not only dietary supplements, but in this case, CBD and hemp products, they compare what's on the label, and they analyze the product for content, in this particular case, CBD or THC or any contaminants like heavy metals. And so you can go on consumerlab.com's website. If you have a subscription to it, if you're interested in these kinds of things, whether it's cannabis or CBD or any dietary supplements, I think the annual subscription to Consumer Labs is like $12 a year. So it's pretty cheap, but a lot of times you can get this data just right off the bat, just going to the website. And then you can click on the tab for CBD, and it will take you to that particular site on their website. And they've analyzed quite a few products, both oral as well as topical, and even some vaping products, if I recall correctly. And so there are quite a few products on there, and it gives you the nice thing about consumerlabs.com is that they tell you the name of the product, who makes it, and then they tell you what the label claim was and what they found in their analysis. And so there's quite a few products on there in the most recent list that have passed muster. So it can tell you, but there's so many products out there on the market, it's extremely difficult to wade through all of them. But this is a nice little place to start. There's probably other websites out there that are sponsored by either cannabis-linked companies, or there may be some independent sites like others besides consumerlab.com. But that can give you some ideas as to which products to at least start with, purchase. It also shows you some products that, like ours, failed to meet muster, failed to live up to the label claim. And some, as we found, some have extra THC, some have other contaminants. So that's the best place. At least that's a good place to start.
So Bill, I get the impression that the USDA or whomever it is that regulates labeling on products
FDA,
hasn't stepped in here. So there's really no regulation on labeling of any of these products?
Well, I mean, yeah, we're in a, as I mentioned, right now we're kind of in a regulatory limbo. The FDA has taken, there was quite a bit of pressure from various constituents and to Congress to make FDA make a decision on how they're going to handle hemp from a regulatory status. And so that process is, I mean, they have come up with a policy and they're submitting it to be, approved and so on and so forth. But I don't know what the results of that policy are at the moment, but by the end of the year, we should know. And so will they regulate CBD as a dietary supplement? They could very well. Will they regulate it as some unique category by itself? That's possible. We'll just have to wait to see. Unfortunately, we're just going to have to stay in that situation for a few more months.
Okay, another question. How long will it take the FDA to approve nabiximols? Is that how to pronounce that?
Yeah, nabiximols. Yeah, so that's, again, it's a product. It's a combination of THC and CBD, about 50-50. And it's been approved in the United Kingdom and in Britain. But I know that the manufacturers of nabiximols, GW Pharmaceuticals or GW Sciences, they have submitted an IND to the FDA, and they're just waiting on the FDA to make a decision on whether or not it will be approved for use in treating spasticity and neuropathic pain in multiple sclerosis patients. So we'll just have to wait and see.
Okay. Next question. Apart from CBD containing foods and dietary supplements, what is the regulatory status of CBD containing products such as body lotions, oils, shampoos, etc.? Are these regulated as cosmetics?
Yeah, that's a good question too. As long as you're not making a drug claim, so say for example, your lotion is not you don't claim on the label that it's for pain relief, like we saw in one example in the talk. It's technically it's a cosmetic. There are some labeling recommendations with regards to cosmetics. So CBD is kind of it's infiltrated in so many market niches, and it's quite possible that those cosmetic regulations may change too, depending upon what FDA does with regards to CBD as a whole. But right now, their cosmetics is, again, as long as you're not making a drug claim, they may be able to slide by. Again, most of the time when FDA sends a letter to a company that makes a CBD product, most of the times it's because that company is making a drug claim. So if you don't do that, then you'll be fine. So I hope that answered that question.
We have quite a few questions here now. So here's another one. CBD affects people differently. How can I understand what is my best dose?
That's an excellent question too. And the short answer to that is we don't know. You may have to titrate it. One of the other aspects of the FDA's decision on CBD is what's going to be the upper level that they will allow to be sold as whatever they want to call it, a commercially available product. We'll just leave it at that. Will 15 milligrams work for everyone? No. will 150 milligrams work for everyone? Maybe, maybe not. And again, everybody, because another thing, because CBD acts on so many different receptors, there could be genetic variability in a lot of those receptors. And so some individuals may be more susceptible to CBD's effects, positive or negative, and some will be less effective and may not have any effects whatsoever. So there's a lot of variables that come into play. That's one of the problems with having a compound that's non-selective. It affects so many different receptors. There's just a lot of variability that can come into play. So I wish I could say that, yeah, this particular dose is going to be effective for everyone. We don't know. We don't know what the FDA is going to be considered as a safe drug. We do know that in those studies that have used fairly large doses of CBD in these epilepsy patients that have Dravet or Lennox-Gastaut syndrome, it's not uncommon for them to see elevated liver enzymes, but oftentimes these are fairly large doses. When I say fairly large, I mean in a neighborhood of more than 500 milligrams multiple times a day. So that could be an issue. But what we really don't know is, even at a low dose that may not have any overt toxicity, are there any long-term effects that need to be considered? And we really don't know much about the safety and or efficacy of CBD products that are low doses for long-term use. So I wish I could be more specific in answering your question. We're still too early in the game to really answer that particular one.
Okay, the next question. If you take thyroid and blood pressure medicines, would it be dangerous to take CBD products as a supplement?
That's an excellent question. It depends upon how your blood pressure medications are metabolized. Again, that's still an area that there's some evidence to suggest that CBD might affect the metabolism of certain medications. And if your high blood pressure medication, if it's metabolized extensively by the liver, it might render it more toxic or less toxic. Most of the blood pressure medications have what we call a large therapeutic window. So it may not have too many adverse effects, but there are some drugs, say for example, like warfarin or other anticoagulants, that have what we call a narrow therapeutic range, which means that if the blood levels change significantly, they can either be more toxic or less effective. So it's still too early to tell, but I would guess, based on what we know about CBD at the moment, particularly in the doses that are available for most commercial products out there, the doses are probably not going to be enough to dramatically affect the metabolism of at least those particular drugs, thyroid medications or antihypertensives. Now, I could be wrong. It could be that there is a long-term use of a moderate dose of CBD might have a tremendous impact. We just don't know. I always recommend people try not to take, if you're on a lot of conventional medications, try not to take too many other dietary supplements, or in this case, CBD, just because we don't know. You might try. Again, I'll just leave it at that. I'm not going to go any further.
Yeah, I think that, we would always recommend, whether you take their advice or not, to let your physician know. Yeah,
unfortunately, a lot of physicians don't know anything about CBD, or, right. And so again, I'm not claiming that's it, but sometimes you may have to rely on your physician to do some homework on his own.
Exactly.
Again, we're still so early in the game, and we know a lot about THC, but we really don't know a tremendous amount about CBD in terms of safety and efficacy and long-term effects and so on and so forth. And again, a lot of that is product dependent. So again, most of these answers to your questions are kind of nebulous, because we're just in a situation where we're too early in the game. When the game just started, I can't tell you what the score is going to be and how it's going to turn out.
Yeah. All right, next question. So a lot of people take arachidonic acids as dietary supplements. And so the question is, does a high exogenous intake of arachidonic acid or any of these other types of fatty acids impact the endocannabinoids or receptors that may alter THC or CBD?
Yeah, that's a great question.
Yeah.
And that's an excellent question. And you know, and on its face, it seems like it would be, you know, hey, if you take some arachidonic acid, then that might help my endocannabinoid levels and that may help me overall. And so the question is, how much of the arachidonic acid is absorbed, and then how much of it actually reaches these sites to be converted into the endocannabinoids? And the answer to that is very little. So do the arachidonic acid supplements, do they have a lot of efficacy? The jury's still out on those. From a hypothetical perspective, you would think that would be a good thing, but there are a lot of other factors that come into play that may render the amount of arachidonic acid actually reaching the cell to be affected by these synthesizing enzymes pretty insignificant. So I wouldn't, based on what we know, I don't think that that's probably going to be have a significant impact on your endocannabinoid levels.
I guess a related question, what oil is the best medium for delivery of CBD?
Oh, that's a great question too. So there are some, so we're finding some interesting results with various oils. People think that oftentimes that the vehicle, the oil, has no pharmacological impact. We're finding that certain oils, when they're taken for prolonged periods of time, can actually have some interesting effects on drug metabolizing enzymes and transporters and wide variety of other proteins. And so to me, the two best, well, I'll just tell you, the three primary oils that are utilized most often are hemp seed oil, olive oil, and sesame oil. And we're finding some interesting results with sesame oil. Some of those are very positive. So to me, if I was going to take a CBD supplement that had an oil, I would probably lean towards the sesame oil because it has some interesting beneficial effects as well. But it doesn't mean that is one going to make this CBD work any better or not? Hard to say. But if it was me, when I buy a CBD oil product, I typically look at either. It also depends upon the quality of the product too. You could have a great oil and the product be really, crappy, for lack of a better word. But my personal choice would be a sesame oil. But that doesn't mean that sesame oil is a heck of a lot better than olive oil or hemp seed oil.
Here's a question from someone who says they suffer from acute anxiety. And so can you recommend any form of CBD or THC that might be useful for treating anxieties or I guess other behavioral type issues?
Yes. So, I know I went through a lot of those results of those clinical trials pretty quickly, but there was, if I can, anyway. So again, it's all product specific. So if I recall the quantity of CBD that was in that they used in that trial for anxiety was relatively small. And so, it was one of the few trials that did have some positive outcomes with regards to anxiety, at least if you're preparing for a talk. So again, if I was that individual, I would go on some of these websites, find a product that appears to pass muster, and then, follow the label directions and just see if that has some effect. So I can't say that it's going to help with your anxiety because there are a whole host of factors that come into, I'm not a psychiatrist or a psychologist or any of those things, but it's certainly worth a try. I mean, based on what we've seen so far with the doses that were utilized in that particular trial, there were no adverse side effects, hardly any side effects whatsoever, except the fact that people seemed to be less anxious. So if with these doses and these products that are on the market, if you can find a product that actually, say for example, there may be one on consumerlab.com that has passed their test, and so the label claim meets what's actually in the product, give it a shot and see. I do not, if you don't get any effects right off the bat, don't start taking, multiple doses over a period of time, because that may be doing more harm. That may actually make you more anxious than less anxious. So find a product that you think might be quality, and follow the directions and see. But don't exceed the dosing recommendations that are on the label.
Is there any evidence that men and women are affected differently from CBD products?
That's a great question too. There's a lot of differences in pharmacology with regards to drug metabolism and those kinds of things between men and women. I don't think there's been a study looking at that at the moment, but just based on what we know about drugs in general or phytochemicals in general, I wouldn't be surprised. Now, are those differences dramatic? Probably not, just based on what we know. But the answer to your question is, again, we really don't know. It's quite possible that there may, for some indications, it might be better for women. For other indications, it might be better for men. Again, we're still too early in the game to answer that question definitively.
And so there were some different routes of administration. I get the impression that dosing it orally seems to be the best way to do that, with some sort of oil. So not sublingual or not inhaling it, but oral.
Yeah, so when you take a drug, or when I say drug, when you take CBD orally, what does get absorbed? Some of it gets metabolized before it actually reaches the bloodstream. That's what we call a first pass effect. And so even though that 6% may be from poor absorption, but it also may be from this pre-systemic metabolism. So when you take a drug orally, that pre-systemic metabolism can have a tremendous impact on how much finally reaches your bloodstream to go somewhere else. And so that's why a lot of these, that's why CBD oftentimes is given sublingually, because it is metabolized by a wide variety of drug metabolizing enzymes in the liver and in the gut. So when you take a drug, or CBD in this case, when you take it sublingually, that bypasses the gut and the liver, and so hopefully more of your active CBD will get into the bloodstream. Now, how much CBD can you take under the tongue? That's still, the jury's still out on that. Certainly small doses, probably fine. But in terms of how quickly CBD will get into the bloodstream, it gets there fastest when you inhale it, right? In terms of fast versus slow. So inhaling it will get there the quickest. The next quickest would probably be sublingually or buccally in the cheek. And so because that bypasses, some of that gets absorbed in your oral mucosa and bypasses the liver. So that may be the second quickest way to get the effect. And then the next one is probably going to be oral, or it may also be topically, transdermally. Because the CBD is a fairly lipophilic compound, it may be able to penetrate the skin relatively quickly. So that's why you see a lot of topical products for CBD. And there are a lot of CB2 receptors that are in the skin that can have some, that if they can be activated, or if they can be acted upon by CBD, they may have some benefits there.
Okay, a couple more questions. So Bill, okay, does smoking weed affect any of the widely used ADHD medicines? I'm not sure if we're talking about marijuana now or hemp.
well, yeah. Well, if you're talking about marijuana, we do know that marijuana can affect drug metabolizing enzymes, and a lot of the question is, I'm trying to remember now, most of your ADHD drugs are metabolized by an enzyme called CYP2D6, and there's a lot of variability in CYP2D6 expression in people. Some people have a lot of it and have to take a lot of the drugs. Some people have very little and they don't have to take much. And I can't recall, I don't think that THC has significant impacts on 2D6. I may be wrong on that, but I know it has some impact on an enzyme called 2C19 and 2C9 and 3A4. So it's possible, but I don't think it's going to have a significant effect. And also, a lot of that depends upon how much THC you actually get into your system to affect those enzymes. And when you're smoking it, because when you smoke marijuana and THC, it doesn't take much to get into your bloodstream through your lungs, and so it doesn't take much to give you an effect. And so, because you have a small quantity in your systemic circulation, that may not be enough to affect these drug metabolizing enzymes if you smoke it. Now, if you smoke a lot of it all the time, all day, that's a different animal. But occasionally, if you smoke it, I don't think that's going to be a significant issue. Again, at the end of the day, as with all compounds, whether they're phytochemicals or whether they're drugs or food or whatever, the old adage, the poison is in the dose. And so that pretty much holds true for whether you're smoking marijuana or not.
So the last question sort of goes to this issue that you've touched on a bit, that we are sort of in the Wild West and understanding exactly dosing and how to use all of these products properly. And so the question here is, and have I lost the question? But what the person wants to know is, how is the state of research for these sorts of products, and are there impediments to going forward with the research at the federal level? What are the state of things of learning more about hemp products? Yeah,
so there's a lot of grants that have been submitted to the NIH and to other federal agencies, federal funding agencies, to look into various aspects of CBD pharmacology and quality and so on and so forth. And so I can't tell you exactly how many of these have been funded, but I know there have been a few that have been funded that appear to be, will probably, if they're conducted and completed, will contribute significantly to the scientific information. In terms of impediments, it all depends upon how well the grant's written and what you're doing. When you're submitting a grant regarding CBD or hemp to a funding agency, I can tell you this, that unless you have that product that you intend to study well characterized and know every little phytochemical and every little nuance associated with it, it won't get funded. So you have to have the capabilities to analyze your product, what we call characterize the material in terms from a phytochemical perspective, as well as from an adulterant perspective. So one of the big stumbling blocks that I've seen, having sat on many NIH study sections, is that if the material is not well characterized, it won't get funded. So in that case, that's the problem of the principal investigator that's submitting the grant, and not necessarily the funding agency itself. But those are criteria, and the funding agencies out there, I know that the NCCIH and many of the other agencies at the NIH, they have pretty strict rules with regards to knowing exactly what it is you're going to study. Because again, plants have multiple phytochemicals, and a lot of factors can affect that. Where it's grown, how it's grown, what condition it's grown under, the time of the day it's harvested sometimes can have a tremendous impact on that. So there's a lot of variabilities that come into play. So again, if someone wants to submit a grant for CBD or for hemp, particularly hemp, you need to have it well characterized. There may be some other, for the longest time, the biggest stumbling block was the fact that it was a controlled substance, and you had to, jump through a tremendous number of hoops to the NIDA to get a license to actually do research on hemp or CBD, but that's no longer the case. And so there's certainly been a large number of grants submitted to look into various aspects of hemp and CBD pharmacology. So it's the impediment, the bar is much lower now than it used to be in terms of being able to navigate the federal bureaucracy, so to speak.
So I think that's it for the questions. Bill, thank you so much. This was really great. I know I've learned a whole lot. It was a lot of
Again, I apologize for kind of getting into the weeds with the pharmacology and the biochemistry and stuff. But again, you kind of, I don't know. It's just, I mean, as a pharmacologist and a professor, you know, that's kind of that's in your genes, you know, so to speak. But it's fascinating how many receptors and how many systems this endocannabinoid system controls. And so with CBD and the phytocannabinoids that can modulate that, it's hopefully, if nothing else, I hope I got across to the audience that the reason there are so many claims out there for CBD is because it works on so many systems, it affects so many systems. And so, but there are formulation and there are a whole host of other factors that can blow a lot of those expectations out of the water. And so that's why it's important for consumers to try to do their homework and try to find a product that I hesitate to mention particular companies' names here on this, but if someone is really interested in a particular product, I can certainly give them my opinion on it. There are some really good companies out there, and there are some absolute trash companies out there too. So you really have to do your homework, and that's why I wanted to give you that consumerlab.com site to go to. But I'm sure there are others. But I know the consumerlab.com guys really well, and I trust what they put on their website.
Great. That's great advice then. And I want to remind everyone who's still on with us that when you register for this seminar, you also can go to the Pennington Facebook page for Pennington Biomedical Research, and we've recorded Bill's lecture, and so you can listen to it later. So it will be available to you there as well. So I want to tell everyone thank you for staying with us. We really appreciate it for our first virtual lecture, and have a good evening. So good night, everyone.